So in this problem, we have a condition that is a plus b plus c, they sum up to pi radians, and we need to prove the following. So what we'll do, we'll start our proof from the left hand side. So on the left hand side, we have sine of the angle b plus c minus a added to sine c plus a minus b, and the third term is negative sine a plus b minus c. Now what we'll do, we're going to rewrite each of the angles. So for the first angle, we have sine of b plus c minus a, but we're going to rewrite it as a plus b plus c. So all we have done is added an extra term here, a, so we need to subtract that a as well. So we are going to get negative 2a because we already have negative a subtracted. So now we get, so we'll go to the next term. We have sine of c plus a minus b. So here also to c plus a, we're going to add b, an extra term, so such that we get a plus b plus c. And we need to subtract that extra term b from it to get negative 2b. And then finally in the third term, we have negative sine of a plus b plus c minus 2c. Now we have done this so that we can replace each of a plus b plus c with pi radians, such that now we have sine of the angle pi minus 2a added to sine of the angle pi minus 2b minus sine of the angle pi minus 2c. Now what we can do, in place of sine pi minus 2a, we can simply write it as sine of 2a. For the second term, sine of pi minus 2b can be expressed as sine of 2b. And for the third term, sine of pi minus 2c can be expressed as sine of 2cy. This can be done because we know that since sine of pi minus some angle theta, that's equals to sine theta. So this is a fact, so we have used it. Now what we'll do, we're going to add the first term and the second term. So here what we have is a formula. We're going to use that since sine alpha added to sine beta, this is simply given by 2 times sine of the angle alpha plus beta over 2 multiplied to cosine of alpha minus beta over 2. So using this formula, so sine of 2a added to sine of 2b, that's simply going to give us 2 times sine of the angle a plus b multiplied to cosine of the angle a minus b minus sine of angle 2c. Now here what we'll do, we're going to use the condition to change a plus b to angle c. How shall we do that? So let's do that. We know for a fact that it's given to us actually that a plus c equals to pi. So that means a plus b can be also expressed as pi minus c. Now if we take the sine function on both sides to get sine of a plus b equals to sine of pi minus c. So here we can use this definition to express sine of a plus b equals to sine of pi minus c as sine of simply c. So in other words, what we are saying that sine of a plus b is equivalent to sine of c. So our expression now becomes 2 times sine of angle c. So here we have replaced a plus b, sine of a plus b with sine c multiplied to cosine of the angle a minus b minus, now what we have here is sine of 2c. Now sine of 2c can be also expressed as 2 times the product of sine of angle c times cosine of angle c. So that's a standard formula that we have used here. So here we know that if we have sine of 2 theta, this is simply going to be 2 times sine of angle theta times cosine of angle theta. Okay, now why we expressed sine of 2c as 2 times sine c and cosine c? Because what we can do, we can pull out sine c as a common factor. This is going to give us 2 times sine c. This is going to get multiplied to cosine of the angle a minus b minus we have cosine of c. So what we have is the difference of 2 cosine function. We can combine them. We are going to use the fact here that if we have cosine of angle alpha minus cosine of angle beta, this is simply given by 2 times sine of angle beta plus alpha over 2 multiplied to sine of the angle beta minus alpha over 2. So in our case, A minus B represents alpha and C represents beta. Okay, so let's employ the formula. This is going to give us 2 times sine of angle C multiplied to 2 times sine of the angle. So we need beta plus alpha. So that means we need C added to A minus B divided by 2 multiplied to sine of the angle. Now we need beta minus alpha, which means we need C minus A plus B divided by 2. Okay, so we have 2 times 2, that's going to be 4. So we're 4 times sine of angle C multiplied to sine of, so here we have C plus A minus B. So what we can do, we can add and subtract an extra term, which is going to be B in our case. So we get A plus B plus C minus 2B whole divided by 2 multiplied to sine of, so here we have C minus A plus B. So what we will do, we're going to rewrite it as A plus B plus C minus 2A whole divided by 2. Okay, let's further simplify. So we will get 4 times sine of angle C multiplied to sine of angle pi minus 2B over 2. We have replaced A plus B plus C with pi radians. Similarly, for the next expression, we have sine of pi minus 2A over 2. So this is going to be equals to 4 times sine of angle C multiplied to sine of the angle pi over 2 minus B multiplied to sine of the angle pi over 2 minus A. Now we know for a fact that sine of pi over 2 minus theta, this is equivalent to cosine theta, which means that we now have 4 times sine of angle C. So sine of pi over 2 minus B is going to become cosine of angle B, and sine of pi over 2 minus A is going to become cosine of angle A. So let's rewrite the expression. So we get 4 times cosine of angle A times cosine of angle B times sine of angle C. So let's compare it with the left hand side. There's a typo here. This should be sine C and not cosine C. And we have successfully showed that this is the expression on the left hand side. So we can say that thus the left hand side of our expression that equals to the right hand side. Hence proof.